Hello, welcome to today's webinar, Accelerate the Machine, Change the Machine Learning Paradigm with Real-Time SME Validation. Thank you for joining us. My name is Cynthia Hart. I'll be your moderator. We'll be taking questions in the Q&A box and we'll answer them near the end of the presentation. And we will be recording this webinar and making it available to you on demand. So looking at the agenda for today, we'll cover first introductions and then what is machine teaching, its benefits, our unique tool and use cases. We'll look at the change of the current paradigm, share 2 demos, as well as some quick wins to implement right away. So let's go ahead and meet our featured speakers for today. First, we have Aldis Erglis. He's our head of technology strategy here at Emergn with over 20 years of experience building software-based solutions for business performance. Aldis is passionate about ML, AI, and is recognized as an AI influencer in Eastern Europe. Next, we have Muntis Ruzitis, our lead data scientist. Muntis is the lead machine learning developer at the Emergn Machine Learning Lab. He focuses on using the latest ML, AI achievements to build the best solutions for client needs. Ariadna Kremkowska, one of our machine learning developers, will be presenting the demos today. Ariadna has participated in several research and development projects in various fields, such as predictive analytics, decision support, time series analysis, and natural language processing. Now, Aldis will start us off with a quick overview of Emergn's Machine Learning Lab.
Thank you, Cynthia. And we, as members of Machine Learning Lab at Emergn, are engaging in different client engagements when we need to apply machine learning. And our philosophy is deliver applied machine learning, the solutions that really work. But aside that, we are working with companies like SAP in our co-innovation projects when we are doing research and development tasks. We are also very active in local communities, delivering knowledge and value to local community participants.
Thank you, Aldis, for that overview. Now, Muntis will continue with the background on machine learning and why the paradigm is changing to machine teaching.
Yeah, hello, everyone. And today I want to focus on what really matters from business perspective and why would people essentially turn to machine learning or machine teaching even further, as we will learn today. And the way we look at it and the way we focus on machine learning labs, we really focus on applied solutions and seeing how the technology can help in business processes and how to make decisions more data-driven or better explained or better focused towards the data. And we actually see that not that many business processes can be fully end-to-end automated. And of course, it makes sense there are a lot of difficult tasks, a lot of exceptions or changes over time that are like very sudden and very niche and can be fully automated. But at the same time, there are plenty of tasks or even plenty of cases in those difficult tasks that are fairly simple or fairly repeatable. And we think that when we propose a solution that would enable for a machine learning model, help automate these easier, more rudimentary, even more, let's say, boring tasks, and at the same time would allow for the expert still stay in the loop and focus on the more challenging work.
Great, thanks so much, Muntis. Now we're going to pause and I'm going to launch a quick poll question. So you should see this on your screen now. Where do you see an opportunity to use machine learning in your organization? So whether that's automating business processes like lead management, automating routine tasks like sorting of an email, fraud detection, data extraction, or perhaps you might see some other opportunity to use automation and machine learning to make your business more effective. Okay, great. Looks like most of you guys have voted by now, so I'm going to close the poll and share my result. So looks like automating routine tasks, for sure, that's something that we would want to make our businesses more effective by eliminating some of that manual work. So thanks for voting.
I think this really shows this right now the answer that routine tasks is something that should be focused on, and we think to try to bring machine learning into business workflow and try to automate, there are multiple really important kind of aspects that should always be fulfilled. And we think that ML always should be transparent and interactive and explainable from business perspective, because at the end of the day, the business experts, the subject matter experts are the ones that know what should the data look like, how it should act, and how it can be used. And therefore, they always should be in the loop and really close to the solution. We see that a lot of, especially business related to the documents and such workflows are related to natural language understanding. And that still, although it's partly solved problem today with machine learning, we're not completely there yet to do anything kind of fully automated from just free text. And it's really important to understand that for kind of more typical machine learning scenarios, it is required huge data sets with a lot of like good coverage, good representation of the actual problem. So it doesn't allow for really kind of quick sudden changes, maybe seasonal changes even, and it requires a lot of kind of pre-work to actually build something. And we see that kind of leaders of the industry are also on the same page of this. We see that humans, natural intellect, and kind of just general knowledge of how the world works really helps to make informed decisions, while at the same time, computers typically in these cases require way and way compared time. And it's mostly because there is like lack of general background knowledge or some worldview. And what we actually see and what we propose is to change the paradigm on how machine learning is typically done. Like a brief explanation on how we typically see some machine learning solutions being implemented is that there is quite a big data set being collected, be it historical data or something that's collected directly for a specific task, and then some data scientist is being asked to look at the data and have some consultations with the subject matter expert, and he builds some kind of a model, and then that is further on used to implement in some kind of a dashboard or something like that. But what we propose and what we believe is that actually the subject matter experts should be the ones that take care of how we look at the model and how we look at the data. And actually, as we know, these workflows change over time, or the reasons you make a certain decisions change over time. So this actual all setup should be built in such a way that it is really easy to change certain things. And it should always be improved over time instead of being kind of one-time deal to make it and then leave it. And we believe that the correct approach would be to implement some kind of a tool that allows for the subject matter expert to do his work essentially. And beneath the hood, there's some kind of a machine learning model that is slowly learning the behaviors and patterns, and over time is able to take over the cases that are simple and are easy to do with machine learning. And at the same time, the more challenging tasks, the tasks that the model is having difficulties with, it can almost like ask for the expert to help with those, and just maybe say, okay, I have a low confidence in this case. Can you look at it? And this would allow for people to focus more on challenging tasks and essentially monitor only the easier ones instead of doing everything. And as we see, machine learning is a really iterative process, and it usually takes some time for data scientists to adjust the models and see what maybe data should be taken into account to make a certain decision. And at the same time, typically these workflows also work kind of iteratively, case by case. So it actually makes sense to look at this as a one huge thing instead of looking at the process, then gathering data, and then for data scientists looking into it. And we see, for example, a scenario where there is some kind of a news aggregation site, or the use case. Let's imagine there's some kind of news aggregation site, or some news that need to be distributed between different departments depending on what's the kind of topic of it. And then what would usually happen is maybe there's a certain analyst or journalist who's having the new topics sent in for him, and he needs to redistribute them further on towards the departments. And he naturally does this through some kind of a software or through emails or something like that. And that's it. That's it. What's required from the expert. At the same time, with our proposed solution, there is like a data scientist and classification model in between that's essentially looking at these patterns and trying to learn what's the reasoning behind them, and trying to do some of this work for the expert. And then after some time passes and the model is running, what should be happening is there should be some parts of the work being fully automated, kind of automatically from expert point of view, or maybe being verified as like a report. Okay, we figured out these things for you. You can approve them and focus on these few that we are not able to solve automatically. And here we are going to overview a few of the slides that are we think are important. So these are the screenshots from our tool. And what's interesting in this kind of machine teaching approach is that the goal for it is to leave all of the control in the hands of the expert. He's able to go through, in this use case, maybe news article by news article, and see what's the reasoning for the model to assign it to a specific topic. And you're able to follow different like accuracy metrics and confidence metrics, and maybe you see that there is a certain problem with a specific type of these news. And if we move on, we see that you're able to, for example, go class by class if there are maybe two classes that are often misunderstood by the model, or maybe it's the other way around. There is not enough data for a specific class. So you can think of these more and adjust your data and adjust your model for both, for the data scientist and for the expert doing this. And if we move even further, we see that this also allows for to see how the model progressed over time, or maybe what's the number of missed cases, or even for the data scientist to look at these things. And it essentially enables a nice interface for the expert to follow on what's happening, and it's easy to understand.
Great, thank you so much, Muntis. Now for our first demo, Ariadna will walk us through what the trained model looks like and how you can quality check it.
Thank you. So let's imagine this from a subject matter expert's standpoint. So let's think of ourselves as one. Let's pause the video for now. So think of this tool as an internal system where new sets of data are coming in every day, and you have a specific task that you need to do with it. And it takes a lot of manual time and effort to analyze the given sets of data. It could be used for many use cases, as we mentioned before. It could be for anonymization, entity extraction, text classification. But for demonstration purposes, we are showing you news classifications into 5 different categories. And those 5 categories are different from each other. So that's why the model is able to learn what are the patterns in each category and how they are different from each other. So with all the text with all the effort that is needed for the analysis of such amounts of data, wouldn't it be much easier if there was a pre-trained model that could give us some suggestions on what this text could be, on how to anonymize each document, and so on, just on the historical data and the patterns it has learned. So on the screen, you can see the main window where the user will be working with. So first, we see the main window is the sample text that we need to label. On the left, we see some statistics about how much data we already have collected and labeled. And on the right, we see that with the pre-trained model imported, we have some information about how confident it is about its predictions. So let's start the video. And here we have the main text that we are going to analyze. Well, let's assume it's from the database. but we can also do a sample import. We could do multiple files, import them into the system, and transform them to given needs, and also assign them a label for each of the samples, which is quite handy. And then we save it, but for now, let's just work with the data we have preloaded beforehand. And here we see the text, we read it, and then the model says that it's a sports category. But in this case, I do not agree with it. I actually think it's the second guess category that it's the second confidence in, which is politics. So since the model is confused, I'll correct it and say politics, then save it and move to the next sample to label it. Now we see a different sample. That is also labeled by the model, but now we can see the difference in prediction confidences. This time is quite confident, and here we agree. So it was fairly successful in recognizing the sports. Then we see a different predictions for the tech category, but this time it's not as sure. It's confusing, it's a little bit with sport, and although it's guessed correctly, we need more data to make the model more confident about the differences between the sports category and the tech category. We also save it, and then we move to the next one. And here, for the last sample, we see that the model predicted sports, and as well as that, we see that the confidence for the sports category is really high. So it makes sense that this is the category that the model learned most about, and it's the most distinct from all the categories. And then when we picked when we selected and labeled all of the data that was needed for the retraining, we can go to the training evaluation and then press the train existing button so that we can take into account the data we had just labeled, so the model can make smarter predictions in the future. And that's it for the first demo, and you will see more analytical insights in the second one.
Thank you so much, Ariadna. So now here's Aldis, who'll share some quick wins you could implement right away.
Yeah, thank you. So we've seen that this machine teaching approach actually helps us mostly with natural language-based use cases. It means when we need some language comprehension, where of course humans are much better than machines. And if we look at this classification, you can see that that is how we at Emergn we are dividing our automation landscape. And if you look here on the bottom, there are three main ways how we look at the automation use cases. There we have task automation, which are usually simple tasks like data extraction or enter data on served documents, like we call it routine operations that could free up the people time if we automate them. And on the other hand, we have them document classifications and classification and automated translation as a repetitive cognitive tasks. And then workflow automation with workflows and case management and approvals, and of course decision automation for more complex cognitive tasks. And what's interesting that in each of these use cases, we have to some extent natural language processing needed. So understanding of the language and some functionality or action based on natural language processing. Therefore, we think that this machine teaching is very useful for automation. And let's look at some use cases, some simple use cases that are based on the document lifecycle, the cycle and the process we have in every company, in every organization. And imagine that if we simplify the document management process, we could say that it consists of three parts. When we're receiving document and do some initial classification, cleaning, and processing document as a next step. And of course, it's finishing with archiving documents. So it's simplified view on document lifecycle. But if we look at the more detailed document lifecycle steps, we see that there are so many different steps, and on some of them, of course, we could benefit a lot from the using machine learning and natural language processing based solutions that help us to do a processing in the best way. But let's start from the beginning. So there is, for example, when we're receiving document, the most popular activities that we are recognizing document, like with optical character recognition and digitizing it, transforming it from the picture to the readable text. And then the first step when we could use machine learning is extract metadata. Imagine that there's incoming document and we need to extract some key fields, keywords, entities that we could extract from the document and actually enrich metadata or add this additional information to some system. And that is where we could use entity extraction. Next is a document routing, probably most popular scenario. When we are by classification of documents, we could route documents in the right direction. And document publishing, if we need to publish something, we need to do anonymization. And again, we could use machine learning here. And let's look at these use cases in details, how we use a machine teaching approach to do this. First, let's look at document entity extraction from the document, or any text. It could be email, for example. And the first step, algorithm is looking at the text, and the data extraction model is actually finding the keywords like organization, address, amount, date, member, person, and so on. And with a data extraction configuration and the pre-trained model, we could extract automatically this information, and then we could enrich a client record with the information like found company, or if it's address or some in client information change, we could automatically extract this information from the document and then enrich client data. Next example is a document classification case. When we pre-train the model, it's pretty the same as Ariadne showed in demo, that we are classifying not news, but in this case documents. So for all the incoming documents, the algorithm could assign a class. Like it could be an email, it could be a contract, invoice, it could be even more detailed classification, like it's a supply contract with amount more than 100,000 and address it to the department X. So with this classification, we can route the documents in right direction in our organization very fast. And the third example and use case is document anonymization. It's becoming more and more popular because when we are publishing any information, like publishing documents and texts on our website, but sometimes it's just we are sending emails outside the organization. And if it contains sensitive information, we need to use anonymization. Usually replacing the sensitive words and data with some labels, or maybe do a data masking by replacing it with asterisks and so on. And how it works, we're training the document anonymization. It's based on the entity extraction. Like in first example, when we're finding the keywords, we're finding the words that are sensitive and replacing them with the labels that are anonymized. So that is how these use cases work. And now let's look at the technical picture, and Muntis will guide us through this.
Yeah, so if you talk about this as a solution from architecture point of view, I'm not gonna go too deep into the detail here, but the general approach is that there is some kind of a machine teaching service that can be used as a tool, as Ariadne just showed, and we'll show in the next demo, is that it's a tooling where you can do your work, and it can be customized, of course, for your needs, for your problem. We have pre-built different versions of that, and it could be further customized. And the other scenario is for example, from all these examples, is you can also do a custom integration, but for example, you are just in your natural workflow, you are routing the documents either via email or some ERP system or Jira or something like that. You just do your work, and then this service is able to take these as a kind of inputs for the machine learning model beneath, and using that as the provided data. And then, as we talked before, as the time goes, the model naturally learns and helps you to deal with the more routine tasks. And then from data scientist point of view, he has a nice interface, a nice backend where you're able to essentially deploy and upgrade your models, and then change them and improve them over the time goes. And you have a nice unified interface that you need to satisfy for the machine teaching service to work, of course, but it has like standardized endpoints, and the data integration is fairly simple. Yeah, it's of course it's the solution is written in Python, and it can be integrated into pretty much any existing workflow as long as it has access to it, and it can be deployed as an on-premise service. That's actually kind of the primary use case it's built for, but of course it can also be deployed into cloud.
So now let's move on to the machine teaching process workflow, and we'll just simply describe how it works. So the first step that we're going to do is label some data. When we don't have a model, let's imagine that this is a task that we are having, that we're just doing. We're labeling some text, either classifying or selecting entities and marking them as a specific object. And then when we're done with the labeling, when there was enough data to represent the categories in the data and teach the model, then we start the training process. It is an iterative process, and at the first results, we can already go and verify how well the model works on the selected tested data. So as you can see on the screen, those are the orange and blue graphs that we will show you later in the demo. But here we can see what are the weak spots of the model, maybe where we don't have enough data, and so on. And according to this verification step, we plan accordingly. Do we need more data of a specific class? Do we think that two models merge together and the model isn't quite sure between the two? So we need more representative data. And then we implement those changes. We either import more data, either label them more carefully, and then as we're labeling and verifying the model's work and correcting its mistakes, we can launch the retraining process. And after it, the statistics of the model will be different because it will take more of the data into account. And by repeating this process, you will find it that the more model learns, the less you need to correct. And that is the main goal that we need to achieve. So now let's move on to the demo, where we will show you a more analytical example of how this tool works. So firstly, we need to analyze the results of teaching the model, as we spoke. So far, in difference to the other demo, we don't have any model and no predictions on the screen, but we labeled some data beforehand. So we see that in the status below, the model is training and it's currently finishing its training. As you can see on the screen, we can see how the errors continue to improve. Now, when the model is trained, we can go to the section of the evaluation and analyze what is the current precision of the model and how it's working with the data it has seen in the first step. Yes, we can see that some of the data is currently missing, but now we can also move to the labeling section of the website, and we can see that now there is a predictions for the unseen data that wasn't there before. It just got there after we finished teaching the model. So moving back to the evaluation, we can see that some of the bins are empty, but that's okay for the first step. As we get more data, we will see that the stats are improving and we have more data to show. So selecting one of the labels, first we can select on one of the dots on this confidence matrix, and we can see that this red dot here was labeled incorrectly. So this text, the model predicted it as a business business news, but actually we labeled it as technology. But here we need to analyze, is it really just the model's mistake, or was it something interdisciplinary and the model and the human would struggle with it as well? And then with the correct assumptions of the model, we can see that its confidence about the category isn't quite high yet. So that's why we need more data that will represent the patterns underlying in the data, so the model can better distinguish between different categories. And that's how we continue with this mindset. So we verify the model, label more data, and then we think, okay, we have a workflow that beforehand we would do just this by hand, which is especially cumbersome, for example, if you work with document anonymization, because the documents can be quite lengthy, and when you lose concentration, when you need to select all of the entities, and then and nothing needs to be missed because some of this info is very highly confidential. But with this, you only need to verify, and the precision of the model gets better and better as the model teaches.
Yeah, thank you, Ariadna. And the next logical question when you're seeing all these demos and explanations is of course, is it possible to apply this machine teaching approach only to NLP models, or it could be applied also to non-NLP models like regression? And the answer is yes. Only thing that we need to take into account that there's a difference between strategies, what we apply to NLP and non-NLP models. In NLP case, as you see, we are working with a data set, and because usually there's a small data set we are starting with. So machine teaching for NLP models, gives us the main advantage that we could start and find the optimal data set. It means selecting the case, the data points, and then labeling it and use data labeling approaches to prepare data. In non-NLP models like regression, we are looking for the best model with existing data, because usually we will have some data, so we use the machine teaching more for monitoring and verification purposes. Yeah, and that's all. That's all for today, and we will be happy to answer your questions.
Thank you, Aldis, Montis, and Ariana. Before we take any questions, just a note that we would love to stay connected and hear from you. So you can contact us if you'd like a deeper dive on the demo to learn more about our tool, or you can reach out to the Machine Learning Lab team on LinkedIn. You can see their profile links to learn more. So we did see one question come in. Can you deploy machine teaching on premise, or does it have to be in the cloud? Aldis, do you want to take that one?
Yeah, that's a very good question. We receive it quite often. It's because not always we could put the machine learning, or in this case machine teaching models, in the cloud because of some restrictions. They must run on premise. For our model, we designed it and built it in a way that it could be run on cloud or on premise. So you can run it on both environments, and most of the solution is built with open source technologies like Python and a couple open source libraries. So it's easy to deploy in any environment.
Thank you so much. Thanks again to all of you for joining today, and thanks so much to our speakers. We will be sending a recording of this webinar, but if anything comes up in the meantime, please do reach out. Thank you all again, and have a great day.